So welcome to our next session, measurement of an inductance. So coming to this measurement of an inductance, here we are having two types of inductances. So one is the measurement of self-inductance and measurement of mutual inductance. We are having these two types of inductances, self-inductance and measurement of an mutual inductance. Coming to this, first of all, let us see the measurement of an self-inductance. This measurement of self-inductance can be done in a different ways by using the different types of bridges. In that one, the first one is the Maxwell's bridge. Second one is the Hayes bridge, and third one is the Anderson's bridge. And coming to this measurement of an mutual inductance, we are having the Heaviside MA bridge. Now let us see how the self-inductance is measured by using this Maxwell's bridge. So first of all, let us see the diagram for the Maxwell's bridge. Here we are having four arms. Let us construct this. First one is the unknown resistance and an inductance. Another arm having an known resistance. One is an known resistance and known inductance, and another one is a known resistance. Now the deflection meter is connected between these two terminals. Let us construct this is the terminal A, terminal B, terminal C and terminal D. Now this choke coil consisting of, this is a choke coil consisting of an R and L. These are the unknown values, and this is an variable resistance R2 and this is an variable inductance L2 which consisting of an internal resistance of R2, and this is R3 resistance and this is R4 resistance. Now the source voltage is connected between the terminal A and C, and the applied voltage is, let us consider this is the E. Now the voltage across the terminals A and B is, let us consider this is the E1, and the voltage across the terminals B and C is E3. Let us consider like that, and the voltage across the terminals across A and D is E2, and the voltage across the terminals D and C is E4. Let us consider like that. Okay. Now, so according to our discussion, this R1 and L1 has to be measured, which is connected between the points A and B. which is connected between the points A and B. In this method, the unknown inductance is measured by comparing it with the standard inductance. Now here the standard inductance is the L2. Now here L2 is adjusted until the detector indicates 0. Now R1 is an unknown resistance. Similarly here L1 is an unknown resistance. L2 is an known resistance, but it is an adjustable resistance, that is nothing but a standard resistance, and R2, R3 and R4 all are the known values. Now if you see the impedance, now the impedance of arm AB, let us consider that is as Z1, which is equal to, it is nothing but R1 plus J omega L1. Similarly across AD, so this is the impedance. So here it is having an R2, an inductance having an its value of L2 and an internal resistance of an R2. So let us say that is Z2 is equal to R2 plus small r2 plus J omega L2. Similarly for arm BC, Z3 is equal to R3, and for CD, Z4 is equal to R4. Now for a balancing condition, here Z1, Z4 is equal to Z2, Z3. Now Z1 is nothing but it is R1 plus J omega L1 into Z4 is R4, which is equal to R2 plus small r2 plus J omega L2 into R3. Now separate the real parts and an imaginary parts. So if you calculate or if you recalculate this one, you will get R1 plus R4 plus J omega L1 R4, which is equal to R2 plus small r2 into R3 plus J omega L2 R3. Now equating the real and imaginary parts, R1 R4, this R1 R4 is equal to R2 plus small r2 into R3. So from this one we can calculate the unknown resistance R1, which is equal to R2 plus small r2 into R3 divided by R4. Similarly, now so this is the unknown resistance value. Similarly, now calculate these two, equate these two values. L1 R4 is equal
మళ్ళీ స్టార్ట్ చేసుకోవాలి.
అది ఆన్ చేయాలండి.